You guys take it away and teach us about detecting and analyzing fileless malware.
Thank you very much. Can you hear me okay? All right.
Let's
go ahead.
All good to go.
All right. You good right here? Okay. Oh, okay. Basically, tell you a little bit about us. We're going to be talking about fileless malware. Basically, we're ethical hackers, DevOps practitioners. We have over 45 years of combined experience, and we're affiliated with a couple organizations: Hack NWA for Northwest Arkansas, Hack Miami, South Florida ISSA, and our team Cyber Squirrels, Beaver Lake CTF, which we'll talk about if we have a little more time at the end, as well as BSides. So first, let's define fileless malware. If we're going to talk about it, we might as well talk a little bit about what it is. Basically, fileless malware is used as an anti-detection technique. If there's no traditional file to scan, to look for signatures, traditional scanners can't find it because they focus very much on disk and looking for basically files that are dropped. Basically, what this technique does is it passes statements directly to a scripting interpreter and may also use DLL process injection. The payload is often obfuscated or encrypted. So how do we catch these critters? Well, you can hide from the endpoint. You can cloak a process in many ways. Hiding it. Using a rootkit. Basically hiding it inside another process, using an injection. Basically, running as a service, schedule task. But regardless, you can't hide from the network. It has to generate some kind of traffic. And so what we look for is command and control, also known as C2 beaconing. Command and control beaconing may use TCP streams, UDP datagrams. It may even use DNS, the domain name system, where we resolve names like Microsoft.com and Google.com to the IP addresses where the system actually lives. And basically, one of the things we'll look at today is the DNS tunneling techniques to hide command and control traffic and how to detect those. Now, the command and control beaconing will stand out to some degree versus normal traffic. So there's a number of products that are used for what's called anomaly detection. And there's a specific one we're going to look at today, but it's by no means is it the only option. There are other products out there. And what we use our anomaly detection software for is to find unusual domains, to search for tunneling, and also to find patterns, that indicate beaconing. So our scenario here, we've simulated a compromised environment. We have 2 Windows workstations in our lab. We have one CentOS Linux system running monitoring and detection software. We have one analysis workstation that's running Fedora Linux. And we have one hostile Debian Linux system running an offensive stack. Now, that by no means am I suggesting any distro is more suited to those roles. That's just how we set up our lab. Our hypothetical users are reporting that their workstations and their network seem unusually slow. So with that said, let's look a little deeper at our stack and what's going on. Basically, for network intelligence, for monitoring and security, we've set up Zeke and RITA. Zeke, formerly known as Bro, is open source software that is designed to monitor what's going on your network, your connections. Very much, if you're familiar with Cisco or other network vendors, it's very similar to NetFlow traffic. So Zeke is monitoring the network and looking at connections and logging. And that's where RITA picks up, where Zeke ends and logs the connections and information RITA is used for traffic analysis. And RITA was created by our friends at Black Hills Information Security. It's a great tool. It stands for Real Intelligence Threat Analytics. And basically what it does is it analyzes that traffic for detecting exactly what we were talking about. It detects beacons, tunneling, and more. You can use it to look at anomalous user agents. User agents being the string that browsers identify themselves as in connections. And in this case, RITA is injecting Zeke logs. There's other options that you can ingest in other recipes, but in this case, we're interfacing RITA with Zeke. And both of these are open source applications. And that's why we chose them for for this presentation, because anybody can download them, install them, and fiddle with the source code. That's the beauty of open source and the larger free software movement. And isn't that the barrier to entry is very low, and you have the right to go in and inspect the source code yourself. So let's see what RITA finds in the Zeke logs in our environment. Zeke, in this case, is running standalone with the default configuration and files going to opzeke. So RITA will ingest the logs, doing RITA import -- rolling opzeke logs Zeke data, and it'll pull it into a Mongo database. Now, to move the presentation along, we're not doing all of these steps live, but trust me, we've done them and we've taken screenshots. So basically, in this screenshot, we're showing the basically RITA going in and showing beacons, and then RITA showing user agents. And you'll notice there's two hosts that are beaconing out, our 192.168.100.181 and .180. And those are our two Windows workstations. So we've confirmed there's some suspicious activity that looks like beaconing. And then we also see some unusual user agents there. Basically, one that identifies itself as PowerShell, and another one that identifies itself as HTTP request, which indicates that it's likely something invoking an ActiveX or COM+ object in order to reach out. It's not a normal web browser. But wait! There's more mischief going on. Basically, remember we mentioned that RITA has the ability to detect DNS tunneling? Well, that clever RITA has detected some likely DNS tunneling. In this case, we see 3,129 unique subdomains in the domain of evil.lab domain. That sounds fishy to me. Probably sounds fishy, doesn't it? So basically, we've identified a likely instance of DNS tunneling, where command and control messages are sent over UDP datagrams over DNS. So in order to investigate our endpoints a little bit further, we've used an automated approach. Rather than wait for memory capture and have some lead time where somebody has to go obtain access to the system and basically install a memory capture driver and go ahead and capture memory to a file and then pull it back, what we've done is automate the process. We've created automation where RITA's beacon report goes in a cron job. It's default. What I was showing you earlier is the human readable format if you give it the -H option. If you don't, it actually puts it in comma delimited format, which is really great to pass to awk, Python, sed, and do all kinds of neat automation with. So in this case, we have the cron job pick up the comma delimited output, and we pass it to Python, which massages the output and resolves the IP addresses to host names and feeds it into an Ansible playbook, because in Ansible playbooks, we prefer DNS host names, because that basically Ansible will take those rules and our variables and our host rules and our settings and process them. So we want to resolve it to the host name. Ansible will connect to our Windows host using PowerShell remoting. And in this case, we deploy winpmem.exe to dump memory. we obtain the memory image, and it copies it to a file share for analysis. We could do the same for Linux endpoints. It's actually even easier. We could deploy AVML or Lime in the same fashion and capture memory to a file and send it to a file share. We'll do the quick rundown here on some of the technology that we did for our automation. We created the cron job that does the RITA import. It does it 20 minutes after the hour and 50 minutes after the hour. And then on the hour and 30 minutes after the hour to give the import sufficient time, we run RITA show beacons on the same data. And then we pipe it to awk, which basically pulls out the second field. And then we run a Python script to format it for the Ansible, so we can feed it as a host list to the Ansible playbook. And then the second half of that slide shows our YAML for our Ansible playbook, our memory triage demo. And what this does is it deploys WinPmem. It dumps it to a file using just the host name, not the FQDN. And then it moves the memory dump to a network share. So once that's done, we're going to recover artifacts from memory in order to investigate this fileless malware. Now, we don't know yet that it's fileless. If this was a real event, we'd be going in and looking at it, and we'd find that there's a dearth of file artifacts here to investigate. So we'd have to dig into this. So we're going to basically recover these artifacts from memory, and the way we do that is when we examine it with our memory forensic software, we're going to look for artifacts. We're going to look for pieces of information that the malware has loaded into memory. For example, host names, IP addresses, files that it's accessing. A lot of that you can hide it, from a user on the running machine. But once you have this snapshot of memory, there's no more hiding. In some cases, it may take a while to find it, and some things may need to be decrypted or deobfuscated. But everything going on in the machine has to be somewhere in memory. And in many cases, things that are no longer happening in the machine leave residue that you can analyze. So we peek at the memory in use by the malware, and we can feed these artifacts back to our detection rules, back to our deny lists. We're going to look especially for our indicators of compromise, which are the changes that the malware makes, changes registry entries, if it does any kind of persistence, and we'll talk about persistence a little bit later. But we're going to look for things that for artifacts that are left, as well as the tactics, techniques, and procedures that our attackers use, so that we can generate alerting and block as many of those as we can, alert on others. Sometimes it may be difficult to tell an intruder from normal activity. So that in those cases, that's where things like our SIEM and our anomaly detection come in. So performing memory forensics, we examine our memory image with Volatility framework. Volatility is awesome. We use Volatility very often, whether in work or in hacking challenges. Basically, there's a number of different functions in Volatility that we use pretty often. PS list, PS tree, command lines, PS scan, service scan, sessions, handles, net scan, consoles, proc dump, mem dump, and Yara scan. And these are basic options that pull different attributes out of the memory snapshot by looking at those file structures in memory. And we're going to look at, in this case, what we're doing is we're drilling down at the suspicious processes. And we found a particular one that is running through remote management, and it's started off a process. So we're going to look on the next slide, we're going to look a little deeper at this process, but we've identified a particular process and we're going to go ahead and dump the memory from that process. So digging deeper into it, using the Mem Dump option, these slides are basically snapshots of some of our analysis, where we find the DNS beaconing out to domain of evil.lab. That sounds very suspicious, and this process is talking to it, making requests for subdomains that are encoded. So this is encrypted C2 traffic, and in this case, we're able to confirm that this process is chatting back and forth, making hundreds, thousands of DNS queries for a unique domain. So this is obviously DNS tunneling confirmed. Now, what we would do basically is, continuing to analyze malware. We would basically take this and reverse engineer it. But getting into reverse engineering is kind of outside the scope of this talk. So we're not going to go too deep into malware reversing. We need another couple hours in order to really get into the weeds on that. So basically, suffice it to say, we found all of this DNS activity. We can also look at file handles that the malware is accessing. And here's a packet capture of our DNS tunneling. While this traffic is encrypted, many DNS C2 frameworks are susceptible to key observation when the client is invoked. You can catch that initial handshake, and that'll allow the traffic to be decoded very often. However, like I said, we're not going to get too deep into reversing the ciphers and things like that. That's a separate talk, and basically we want to kind of stay within our time slot. So let's look at the other beacon. We also saw another beacon from Workstation 2. Basically, RITA logged this as a suspicious user agent, and our simulated malware is a little JScript that's running through cscript.exe. In this case, we can see this C2 traffic, and a lot of the time the malware will use HTTPS to encrypt web traffic, or it may use some other cipher. And normally we'd catch this with a TLS interception proxy. But if for some reason you're not doing that, you can always try and capture the handshake, or decrypt it, try and decrypt it out of the memory on the client side. Sometimes it's not even encrypted. And if we were to look at the memory, we were able to recover at least half of this conversation from the memory of the process. So we have enough to drive some analytics. Now, the next step, once we see what's going on, is finding the persistence. And what we want to look for is scheduled tasks. We want to look for registry entries. We want to look for remote re-execution. We're going to look for WMI persistence. We're going to look for PS exec. We're going to look for PowerShell remoting, and basically any methods that the malware might use to remotely re-execute, or backdoors or malicious fileware planted, and we'll have to identify all of those and remove them. So it's important to see all of the handles that are opened up by our malware, which is your Volatility plugins can determine what file handles were opened by which processes. So basically, now we'll go into a little bit more of a demonstration of the different techniques that we used. Now, we'll go into it as much as time allows. However, we also want you to be aware that you can do this at home. We've uploaded our artifacts to beaverlakectf.org /Fileless 2021. So you can do this at home. Basically, you can download the our YAML file. There's another one I'm going to upload from the server side, which will be up there. Wanted to make a few changes to it and sanitize a few things in it before I upload it. But the memory dumps and the packet captures are in there, as well as some recipes and the cron job. And I'll see if there's any other artifacts that might be interesting to you.
Yeah, and you guys have about 20 minutes if you guys want to take your time on those demos.
Okay. Sounds good. All right, let's see. You wanted to talk, before I do that, I think Evan wants to talk a little bit about a set of Yara rules that he's been using which have been very helpful for analysis.
Yeah, let's go over some of the information gathered from RITA first. All right, so when you look here, you can see user agent strings. You have some IP addresses here and some other information available. So if you take these user agent strings, you could put those into a Yara scan rule in Volatility. I mean, you could just take little pieces of it that you know are unique, and then you pass that in there, and then it's going to help you identify what the process is that has that information. And so when you're running a Yara scan, you want to also make sure that you're accounting for 1 byte and 2 byte words. So you just tack on hyphen wide. I was going to show this stuff in real time on my VM, but my machine yesterday decided to blow up in Volatility 2. The Python 2 libraries on the new version of Kali, just so everybody's information, they're no longer supporting Python 2. So you have to use Python 3, which it has all the functions in Volatility 3. You'll have to use Volatility 3, but it doesn't give you some of the super cool output. You'll have to tack on more output options and whatnot. But we'll just basically step forward a little bit here. And if we look here also, we see domain of evil.lab. So if we make a YAR rule, it's -YAR -rules equals, domain of evil. Just put that in there. And it'll show you the process in the memory dump if you wanted to follow along and see which process actually had that with the files available. But from there, when you have the process, then what we're showing here, when we look, you'll want to dump once you get the process, you'll want to dump the VAD pages. We should have put VAD dump on here, but my bad. So
yeah, I found a lot of it with Mem Dump.
Yeah. But basically, you just do a VAD dump on the process PID itself, and then you can, run binwalk and other tools against that, and then grep it if you want to, and do disassembly and everything. But that's definitely part of the process. You want me to bring in that screen over there?
I have done an article to extract this first. I forgot I bzipped these to upload them, and I bzipped the original files, so I got to extract them again real quick. Because we put them up on the web and bzipped them so you can download them quicker. But I realized I bzipped the copies that are on my laptop here. The other thing we wanted to mention for anybody analyzing these captures, the workstation 2 was talking to the second domain, domain of evil 2.lab. So you may not find the artifacts from domain of evil.lab. You're going to find domain of evil 2.lab on that other box that was running the JScript versus the workstation 1, which was running the PowerShell. It's fun.
So setting up that live demo, there were 2 questions. Will the presentation slides be accessible?
Yes,
And it looks like the details were a little fuzzy in the display for some of the more smaller, like Wireshark PCAP captures.
Yep.
So
yes, the slides are already up on that the site that we're going to mention on the last couple slides. So we'll be giving you a link, and the copy of the slides as well as the PCAPs are already up there. So you guys will be able to load those PCAPs into Wireshark and analyze those analyze the memory dumps in Volatility yourselves, basically. So we'll cover that in a sec. I'm trying to increase my font so you guys can see this. I just want to make sure it shows up good on the screen before I start presenting it.
yeah, it is a little difficult to see. Let me try to remove myself. And can the audience just type in the chat if you guys can see the terminal prompt? So guys, it looks like the crowd is able to see the screen a lot better now,
Okay.
and they can see your command prompt.
Can you guys see that? I'm trying to get this font to increase a little bit. I don't normally do these with my laptop. With this.
I think that actually looks good, especially if they put it in full screen. They'll be able to see it pretty clearly.
All right. All right, my keyboard has stopped working. This is one of the reasons why we did this beforehand and took screenshots, because you never know what's going to happen during a live demo. And right now my keyboard is not behaving. So I can use the mouse, but hey, you got a USB keyboard I can plug in real quick? Yeah. This is a first. Yeah, I just extracted these images here, and I'm just going to go into step into them with Volatility a little bit. And
I'm going to have to relaunch that terminal.
okay, here we go. Let's see.
Windows 8 Service Pack 1.
SP1X86. That was in workstation. Okay. So -F -F is going to tell us which file. We're going to look at workstation 1. And we'll, in this case, we'll run PS list here. And my apologies too. This laptop is a little bit slower here than it would be with my desktop, but Evan has the better the better presentation, area here. So we we're basically doing this with a little bit slower mobile equipment. So anyway, if you can see this, hopefully this is large enough. I was trying to bring the font up for those of you who may have trouble seeing the smaller font here. But basically this process, this PID 2508, this is the process that if we look through the various processes with Yara, and we look at network activity, this is the process that was beaconing out, and where we find the matches for our C2 domain. Second. So we're gonna dump the we're gonna go ahead and dump the memory, the different processes running in the memory inside them to this analysis folder that we made. It's going to take a moment here to rip these artifacts out and create them into files, and then we can look through them with Yara or with grep, or we can run strings on them. We can take these particular memory images or the binaries, and we can even load them into a debugger and look at them in Ghidra and some of our reversing utilities. We wanted to avoid getting too deep into reversing, because it's easy to it's easy to talk about reversing for an hour or two, and we'll lose all track of time. We'll go down that rabbit hole. And if anybody's interested, we can go into that another time. There's a talk up on YouTube that I did talking about 64-bit ARM reversing, but we can if there's interest, we can cover that topic for x86 64 as well at some point, depending on what where the interest is. But this may take a little while. That was another reason why we figured we'd take screenshots from the analysis earlier, because this is a little bit of a time-consuming process, and running on the laptop, it's a little bit slower. So I may stop this here. Evan, is there some stuff that you'd like to show them as well?
I'll show them. So when we earlier when we saw in RITA some outputs where we basically showed some domain names and some user agent strings, we can go ahead and do a Yara scan. We'll add a Yara rule. We say domain of evil. Okay. And then that should show up pretty fast. If we don't see anything, what we have to do is right by default, it's going to search for the 1-byte characters, and you can do tac wide to get the 2-byte characters. So this should find some results quickly enough.
Oh, and for those of you who want to get copies of these to get your hands dirty, this does run faster, in my lab, when we run this on the workstation. So this may not be something that you want to do with a laptop unless you want to, go make a sandwich while some of these things are running. Basically, but you can get these artifacts. It's beaverlakectf.org/fileless2021. And I enable directory browsing so you can see all the artifacts in there. And I'm going to drop a few more things in there tonight. And if anybody has any questions or requests, I can drop a few more things in there as well too, so that you can replicate this in your own environment. Specifically, there's a playbook for the server side of this exercise that basically I'm turning a few things that I hard coded there into variables to make it easier for you to customize it to run in your environment. So that'll be up there too. Basically, while this is running, does anybody have any questions? We can probably go to questions first.
Real quick, since that's taken.
So there does appear to be one question, and it's actually a commented question, but it says, I think I understand your basic analysis process, but what was the trigger that said you need to go do this research? And what is your research to purge it?
I'm sorry, are there research to...
You talking about the initial vector?
Exactly, the initial vector. Yep.
That would be the output of RITA. So we take the Zeke logs and run RITA on it for anomaly detection, and that's what showed suspicious user agents, a couple suspicious user agents, and suspicious communication involved with it, and then also the domain name. So those were the indicators that were pivoted on within the memory dump as a Yara scan to identify the processes that then we were able to dump out and get more information about what that malware might be.
Now, normally, your SOC is going to have your security operations center, or your NOC is going to have, depending on the size of the organization, is going to have some additional telemetry coming in from their antivirus. They may have some EDR products in there, or they might be running OS Query or Velociraptor. And basically, they're going to see that there aren't the traditional, IOCs where we have a particular file that's a culprit or a web browser plugin or anything like that. So when you're encountering fileless malware, you have to go to these deeper types of detections, where you capture the memory, or you'd capture both the memory and the disk within case. In this case, we're using just volatility, but there are some additional options. But whatever your preference is, basically you're going to end up doing memory analysis because these artifacts are not persisting on disk. Except in the case of Workstation 2, if you look in there, there is a scheduled task that invokes that JScript payload periodically, but it's not, it's basically, updating and reaching out and basically updating itself. It's not, generating additional disk artifacts. So that's the scenario that we're simulating. Now, the question was also what brought us to do this. We've had some questions from some friends, basically, who were in from some friends who were doing analysis. Some of them in forensics and some of them in law enforcement, who have asked us, hey, we're seeing some of these cases where they're not dropping artifacts on disk, where they're just running in memory, where they're using techniques like WMI or process injection, or they're creating VB script or JScript or PowerShell scripts using the using the base 64 encoding, and those are pretty easy to find when you do the when you do the process list and the command lines in Volatility, and you'll see the you may see the PowerShell with the obfuscation, but a lot of the time those are just base 64 encoded, and sometimes there's an additional level of anti-forensics going on in there where they pass it a pre-shared key, and in that case they have some other form of encryption, even sometimes AES 256 in play, and then then you basically have to look at that process and recover that key. In many cases, they have to pass it initially in order to decrypt the malware payload into memory. So if you get good memory forensics, you can recover those artifacts and be able to decrypt the payload. But once again, some of that can be time consuming, and it can take a while to go down that rabbit hole. So that's kind of outside the scope of what we were going to talk about today, which was the detection and the basics of memory analysis. So let us know if you'd be interested in an advanced memory analysis and reversing presentation at some point in the future.
Okay, and you can see we're getting some results back. It's just that the disk on this laptop is slow. But basically it's given the process ID, and then you would go do a VAD dump the memory pages out and inspect those to find out more capabilities and see exactly what it's doing. But like I was saying, the pivot was the data coming out of RITA, the free anomaly detection tool, and so that's what's bringing the eyeballs to it to go, hey, this machine did this. Okay, let's take some of those user agent strings, just pieces of the user agent strings that are unique, and see if that returns data. And then we have here, we put in domain of evil, and we got our process back, the process ID.
See if we can go to that. Which button is it for that screen?
Oh.
I want to make sure we cover the thank yous. Okay. Here's the tools used: Ansible, RITA, Volatility Framework, Wireshark, Zeke, and Evan's a fan of this Yara IDD QD God mode rules.
Yeah, if y'all haven't heard about that, that's from Florian Roth. Go check out the God mode Yara rules. You're looking for stuff that's when you're hunting on the machine in memory, like curl, wget, invoke web requests, any kind of tool like that that's going to go out and grab information. Another thing that I wanted to say also is the tool RITA. I'm a huge fan. My mother, her name is also RITA, but she passed of cancer in 2019. So I'm glad that I can use a product that looks that's looking out for people like this. Appreciate y'all.
Okay, we already went into the questions. Give some credits here and some contact info. My name's Christopher Williams. You can reach me at gnulinuxadmin@gmail.com. Evan is sharing his Twitter handle, and we also have some additional Twitter handles for some organizations. Our main hacking team that we play in. You've probably seen us in many of the CTFs in Florida. Hack Miami, BSides Orlando, Jacksonville, South Florida ISSA. Hack the Flag. If you've been there, you know us. We'd like to thank the developers of Zeke, RITA, Volatility, Wireshark, Florian Roth's IDD QD, Yara rule set, and all the other great open source tools. We'd also like to thank BSides Tampa for asking us to submit an RFP and come and speak. Hopefully you guys enjoyed this. We appreciate feedback. We'd like to also thank our colleagues that we work with every day. We enjoy that discourse of learning from other people, teaching other people. It's a great ebb and flow, and it's awesome. So shout out to our colleagues and everyone in the cybersecurity community. We love working with you guys. We love sharing. Everybody, we all learn from each other. We all get to teach each other. And it's an awesome community to be part of. Now the slides are up at that link that I gave you, beaverlakectf.org /fileless 2021. So there's a PDF version of the slides up there that has all those links and everything in it. And if there's any additional stuff that you'd like to find out, you have any questions, you can always reach out to us on social media. So we'd like to thank you. And Evan, you got any last words here too? I'm sorry, I get my soapbox now.
This was it's been great doing the presentation. I appreciate the South Florida, or in the Florida in general, cybersecurity community. I had so much fun. I feel like that really opened up my understanding of what my own skills were, being there at the CTFs and understanding, whoa, I can do this, and it's just it's a great experience. And so the stuff that you guys bring just has a great impact on people. Appreciate it.
Hey, thank you so much, Christopher and Evan. This was a fantastic presentation. I think all of us are leaving this room a lot smarter. So we really appreciate your efforts, and we will definitely be on the lookout for the additional talks that you guys will have in the future. So with that being said, I think that this session is good to go. We're wrapping up, and we're welcome to converse in the networking platform. And so it looks like we have one. Yep. So we have one last question.
Sure.
What was the website? And
where the cursor is on my screen share.
It's beaverlakectf.org. We haven't finished the website yet, so it's got an Apache. It's got a default Apache or Nginx page up on it. But if you go to the /fileless malware, or I'm sorry, Fileless 2021. So it's beaverlakectf.org /Fileless 2021. And we don't have a certificate up there yet, so just the HTTP. There's nothing secure up there yet. It's just we're just sharing files.
I went ahead and shared that in the chat for everyone as well.
Okay, awesome. We'll try and navigate over to that speakers, the network lounge and everything in case anybody has any other questions or anything. So thank you very much. It's been an honor.
Thank you.